Okay, the very first question they have for graphing quadratics, they want us to tell all the information we can about a certain function. So they've given us the function y equals x squared. Okay. Now, technically, this could be in any three of the forms we have over here, right? We know that there's a standard form, a factored form, and a vertex form, right? But because we're doing transformations and everything of the vertex, we're going to be using vertex form for this, okay? So I'm going to compare this to what a vertex form normally is. So when you take a look at this, what is my a value in this function here? Well, the a is the variable before whatever the x is squared, okay? So because a is multiplied by, if you don't see anything, we imagine there's a 1 there, okay? So in this one, our a value is equal to 1. Now if you look, normally there's an x minus some number. Do I have anything in the brackets? Or are there even brackets in this question? No. So in this case, when we're adding or subtracting, if there's nothing there, that means our h value is 0. Okay? And what is our k value? Do I have anything here?
0.
For k? Yeah, that's right. My k value, sorry, I usually do those in the other colors. H is blue, k is green. K is also 0. Okay? So in terms of in vertex form, we have an a value of 1, h of 0, and k of 0. So in other words, we're moving left or right, 0, and we're moving up and down, 0. So essentially we're not transforming this parabola at all. So our vertex is related to h and k. Our vertex is technically, could be written like this, the opposite of what our h is here. So whatever h is, technically our x value in the vertex is opposite our h, and our y value is just whatever k is. Does this make sense to you? Yeah. So when we're trying to find a vertex and we're looking at vertex form, whatever h value is, we essentially put the opposite sign in front of it. It gives us our h, and our k value is what our y will be. So for our vertex here, what is our h value?
H value is 0.
0. What would negative 0 be? Still just the number 0. Okay, so we know our x value is 0. And what's our k value? 0. So where's our vertex? 0 and 0, which is the origin. That's right. Yeah, we're exactly on the origin. So let's try to make sense of that a little. Let's put a little graph on here. Okay. So we got our graph. That means our vertex is right at the origin. We have a vertex right there. Okay. Next question asks us for the axis of symmetry. Okay. Now, in order to find the axis of symmetry, yeah, it's whatever our x value of the vertex is. So we also know that our axis of symmetry is equal to the x value of the vertex. So our axis of symmetry is at 0. We know that from knowing the vertex. So our imaginary line that cuts this parabola in half runs right down the middle. Okay, so there's our axis of symmetry. So that's 2 parts. What direction is this headed? So I would assume they mean opening. So they want to know what direction this parabola is going to open, if it's essentially up or down. Now, which variables does that deal with when we're in vertex form, the openings? Is it a, h, or k? You know? So if I got to figure out if a parabola opens upwards or downwards, which of my 3 variables, h, k, or a, which one affects a parabola opening up or down? A, that's right. What is our a value? We have it here, 1. Well, it deals with whether a is positive or negative, right? So if a is positive, we open up. So in other words, we have a parabola that looks like that. And if a is a negative, open down. So we have a parabola that looks like that. So our a is positive or negative in this case?
Positive. 'Positive. 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 '
It's going to open up. Good. So we know it opens up. That's another thing we have here. Optimal value is a max or min value. So what they're talking about, which deals with opening upwards and downwards, is the highest or lowest point. And a parabola either has a minimum or a maximum depending on which way it opens. Okay? So if a parabola... Yeah, that's right. Because this opens upwards, in this case, it's a minimum value. If it opens downwards, in that case, it'd be a maximum value. Okay? So you're right. In this case, we have a minimum value, which is where our vertex is. So we know that that is going to be the minimum value. So that's our min. State the min or max y value. What is the y value of our minimum? What is y equal at this point? 0. So just like the axis of symmetry was the x value of the vertex, your minimum is the y value of the vertex. Okay, so our minimum is 0 in this case. Shape of the parabola?
She means like it's the same.
Okay. Wide or thinner? Is that what you're talking about? Compressed?
Oh yeah, wide, narrow.
Oh, okay. Okay, well, right now we're actually working with the original function. This is our parent function, y equals x squared. So my a value is 1, so it hasn't gone wider. Like, say this is our normal. We haven't made one wider, and we haven't made it thinner. It's exactly what the normal one is. So yeah, so it's the original function. So we would just say it's the original one. In fact, what's the last question? State, shift, subtract. So if we were to actually draw this parabola, we should probably draw it out. If this is our vertex here, and it's a normal parabola, I know I go over 1, up 1. Do you remember these rules? Over 2, up. Do you know how many?
Yeah.
If I go over 3, how many should I go up? Yeah, that's right. We just square it. So we have our original parabola. This is a normal parabola. One of the next questions asks us for x-intercepts. What are our x-intercepts in this question? When we take a look at this, how many times does it touch the x-intercept? Once.
0.
Yeah. So our x-intercept. X-intercept is 0. What's our y-intercept?
0.
Same thing, yeah. Is 0. And finally, has this been shifted? Has the vertex been shifted up or down or left and right from the vertex? No, there's no shifts. So we have no shifts. Okay? Does that make sense? So let's show you the entire page. So that's everything we did for our first. Okay, so we're in vertex form, and we need to find the y-intercept. So there's 2 ways we can go about doing this. We can change this. Remember, we're in vertex form right now. So I can change this from vertex form into standard form. I can tell you why after, because standard form will make it really easy for us to figure out what the y-intercept is. Or I know a y-intercept is going to have an x value of what? Right, our y-intercept, the coordinate is for sure going to be x is 0, and we'll be solving for the y. Okay, so in other words, I can plug 0 in for x and solve the equation.
Good.
Yeah. So let's plug that in. We get y is equal to 0 minus 25 squared. What's 0 minus 25?
25 minus 25.
Yeah. Squared. Let's figure that out. So negative 25.
625.
Yeah, 625. Good. So your y-intercept is at 0 and 625. Okay?
That's how you figure it out?
Yeah. Another way you could have done this, okay, and what we'll do is we'll do it on another page. I was saying turning vertex into standard form. Okay. The other way I said we could have done this is if we actually go from our vertex to standard form. Okay. We're in vertex form right now, so we'd have to change it to standard. In order to do that, I would expand and simplify. So x minus 25 to the power of 2, it actually means this bracket times itself twice, right? So do you remember FOIL doing that stuff? X minus 25 multiplied by.
Isn't this expanding?
Yeah, this is exactly it. That's how you get from vertex to standard form, you expand. Okay? So you got to expand to go from vertex to standard form. So we would do our first terms, x times x. Yeah. X times negative 25.
Negative 25 x squared.
Yeah.
And 625.
Yeah, good. Plus 6. And the reason it's positive is because it's two negatives times each other.
So do those two make negative 50x?
That's exactly right. Negative 50x plus 625. And lo and behold, let's copy this guy. Paste him here. We are in standard form. Didn't take very long, right? Now, this is what's neat about standard form. Here's our A value. Here's your B value. And here is your C value. What did we find the y-intercept to be before?
625.
Yeah, it was at 0. Yeah, 0 and 625. Do you see that number at all in standard form? And what we found?
Oh yeah.
Yeah. C. Oops, sorry, let's see that in green. Our 625, or our C value, that is the y-intercept. So that's the other way you could solve this. Anytime you go into standard form, your C value tells you exactly what the y-intercept is. We always know the y-intercept will have an x value of 0. Whatever the C value is, that's your y-intercept. Okay, so we did it two different ways. You could have solved it by putting 0 in for the equation, like we did, or we could have changed it to standard form to find it. So we're in our vertex form, we got to find our x-intercepts. In order to find x-intercepts, we actually want to get into factored form. Okay. Problem is, from vertex form, to get into factored form, we need to be in standard. So we just did this. How do I go from vertex to standard form?
You make that bracket two brackets.
Yeah, we expanded, right? So we have our vertex form. Change it into our standard form. So we said this before. What's it called? We will expand, right? So let's expand this. Y is equal to x plus 18 squared minus 7. So because it's squared, we multiply the brackets by themselves. Minus 7. We do FOIL, we'll get x squared. What's x times positive 18? And then, yeah. Let's trigger this one. 18 times 18, 324. So plus 324 minus 7. I can drop the brackets and combine like terms. So we get x squared, 18 plus 18, 36x. And 324 minus 7 is going to be 317.
Is that right?
Yeah, that's right. Now, what'll be tough is going from standard form now into either, there are two ways we can do this. We can go into our factored form. And in order to go from there to there, we factor, right? Now, this will be a difficult one to do. We have could be a possible prime number. There are probably a lot of options. The other thing is, okay, so this looks like it's going to be pretty difficult to factor. So what we're going to do is we have it over here. We're going to use our quadratic formula. Okay, and the quadratic formula, relates to our standard form. So we had to go to standard form anyways. It was important that we did that. So in our standard form, our a value is 1. Our b value, so these are the b's we put in, is 36. And our c value is 317. Okay? So with doing this, we're going to find out what it is. And what we're solving, see how it's equal to x? We're finding our x-intercepts. So we're going to plug those values in. We get x is equal to negative. Our b value was what? 36. Right? Plus or minus.
It would be 36 squared.
Yeah, exactly. Plus or minus 36 squared. Now, minus 4, that's just a part of this equation. Our a value was 1. And our c value was 317.
That's going to be a big number.
Yeah, that'll be a big number. That's what we got a calculator for, right? And it's all divided by 2 times, what's our a value?
So it's basically 1. I mean 2.
Yeah, it's basically 2. Let's try to evaluate some of this. So we get x is equal to, this becomes negative 36, plus or minus, and I'm going to do everything in black now. I just plugged it in that way before. Square root of, and it'll all be divided by 36 squared, 1,296. Now, think of this like negative 4. So we have negative 4 times 1, gives us negative 4 times 317. There we go. So we get subtract 1,268. All divided by 2 times 1 is 2. X is equal to plus or minus. Now here we got to find the square root of this number. So 1,296 subtract 1,268. So we just subtract the two numbers in the root. 28. So we're looking for the plus or minus the square root of the number 28. Remember, what we're trying to find here are our x-intercepts. So, and then finally, before we do our special step, plus or minus square root of 28. So I have that number in the calculator. I hit square root. I'm going to say it's 5.29. Okay, 5.29 divided by 2. Now, the reason I have this plus or minus is because technically the square root of 28 has two answers. It's either positive 5.29, because a positive times a positive gives us a positive, or it's negative 5.29, because a negative times a negative still gives us a positive answer. So that's why they draw this symbol here in front, plus or minus. So we're actually going to split the equation from here. Okay? So we split the equation, we get x is equal to negative 36 plus 5.29 divided by 2. And their other option is x is equal to negative 36 minus 5.29 divided by 2. Which makes sense because we're looking for two x-intercepts now. And by looking at this, yeah, we know that we have two x-intercepts. So we figure this out. Negative 36 plus 5.29 divided by 2, 15.355. So see how we had a decimal as an answer? But you couldn't quite tell by graphing it and looking. So 15.3.
Wouldn't you just do 15.4 or what?
Yeah, you can round it like that. Depends what your teacher wants you to round to. And in their other instance, so that's an actual x-intercept. So what that's saying is x is negative 15. Yeah, we'll round to the 0.4 and 0. In our other one, we have 36, or negative 36, minus 5.29 divided by 2. 20.64. Let's run into 20.6, right? But anyways, it's x equals negative 20.645. Yeah. So in this one, we said it's approximately negative 15.4. This one will say it's approximately negative 20.6. Okay? So our x-intercept is negative 20.6 and 0. So there's quite a few steps in order to figure out what our x-intercepts were